Hello everyone, my name is Ahoud Ba'afif. In this short video, I'm going to present my Teach 1 assignment and I will be doing question 3 under benchmarking clinicians. This presentation was prepared as part of HAB 725 course on statistical process control taught by Professor Farouk Alimi at George Mason University, Department of Health Administration and Policy. Here is the question. The following table shows the observed and expected length of stay for 30 patients. Use paired comparison of means to test that the expected and observed length of stay are the same, assuming normal distribution of the length of stay. Use risk-adjusted control chart to plot the data. Make sure that control limits are derived from the expected values and observations are contrasted to these limits. This analysis can be done using Tukey or XMR, and you need to select which chart produces tighter control limit. The conclusions you arrive at based on paired comparison of expected and observed length of stay and the risk-adjusted control charts should be the same if in both situations we were calculating the control limits from the same number of cases. Are they? So, first of all, we need to download the data. Once we open the data in Excel, we notice that the following table shows the observed and expected length of stay for 30 patients. In this question, we asked to use paired comparison of means, use risk-adjusted control chart to plot the data, use Tukey control chart to plot the data. Then we have to decide which control chart produces tighter control limits. Moreover, we're gonna do t-test analysis to verify if there is a statistical difference between the means or not. So, in order to use risk-adjusted control chart to plot the data, we have to calculate the grand average, the difference which will be used to calculate the grand standard deviation. Next, calculate the expected grand average using average function. Also, we need to calculate the expected grand standard deviation using standard deviation function. Finally, calculate control limits. The upper control limit is the expected grand average plus t-test value, which is constant based on t-student distribution, times the standard deviation for the case number. However, the lower control limit is the grand average minus the t-test value, which is 2.756 times the standard deviation. Here you can see the screenshots of the steps which we followed in the previous slide. This slide shows the risk-adjusted control chart XMR. Next, we have to use Tukey chart to analyze and plot the data. First, we need to sort the data. This slide illustrates the steps to create Tukey control chart. First, calculate the average using median function, then calculate the upper and lower fourth. After that, calculate the force spread, which is the difference between the upper and lower fourth. Then calculate the control limits. So, here is the Tukey control chart, which used to plot the data. After doing the analysis, we can see that risk-adjusted control chart XMR produces tighter control limits. Moving on, the next step is to perform a paired sample t-test analysis to evaluate whether or not the expected and observed length of stay are the same. So, in Excel worksheet, click on the Data tab on the title bar, then click on the Data Analysis icon. When the Data Analysis window opens up, select that t-test, which is paired to sample for means, then click OK. After that, the dialog box will appear with the input and output options. Select the expected length of stay values as variable 1 range. Select the observed length of stay values as variable 2 range. Then enter mean difference as value 0 and alpha value as 0.05. After that, select the output range. Don't forget to check the label box. Then we can see the mean test statistic, p-value, and p-critical values for both expected and observed length of stay. Therefore, we can conclude that there is a statistical difference between the means. I hope that you found this presentation helpful and thank you for listening.